Hello everyone, this is Core Metaphor. So I was thinking, what can we do? What can we look at? So I think iteration is still debatable, and so I thought about looking at dynamic iterations, right? So if you're given an array like this or a list like this, it's very easy to iterate over here linearly, right? But it gets hard if I tell you come from 0 to 2 and then do some operations and some functions and some return values, and if a condition is met, start from here, then start from here, dynamically jump back and forth, right? And one of the best example of this is the minimum jump question from LeetCode, which is that you're given an array, right? A list is given to you. This is the index, and these are their power, which means here at index 0 I have a power of 2, which means I can either go to 1 or either go to 3. So we have to have a minimum jump. In minimum jump we need to cross this one. So you see from 2 I'm gonna propose to go to 2, from 0 to 2, because the index is greater. I'm not gonna come to 1. I'm directly gonna go to index 2 because the value, the power is higher, so I can jump more, right? And then from 3 I'm gonna come to 5, and then from 5 I'm gonna go all the way to the end, right? Now you see, we iterate index 1 and 2. Once our condition is met, then we go in here, and then we don't do this again. So then I want to start, my positions should be starting from here, and then I go ahead, and then I go ahead. But while solving this problem, there is one thing more that you need to consider, which is, you see, from index 0 I go to 2, there is some kind of pattern developed. From 2 I go to 5, from 5 I go to 7. How? Because this 2 is the addition of 0 plus 2, this 5 is addition of 3 plus 2. So I'm not going to say loop till the 3. No, I'm going to say loop till 3 plus 2, right? And then all the way to 7. 5 plus 5 is 10, but we don't have elements, so it's 7, right? So now what we got to do is go back. um, we will initiate a position. You see, this is simple. You got to just start code, right? Position is equal to 0, power is equal to array of the position. You see what you're gonna do? Nothing. Okay, let's initiate a jump variable also. So far we have 0 jumps, right? So we are right here, we haven't jumped anything. So now we will say, oh, where should I start, blah blah blah. Well, nothing. Just, you see, you're standing here, you gotta think, okay, I can go in here and here. That's how metaphorically, actually, you're transferring your mentality, your mind function, or a neuron that works on this, a simple neural network that you have in your brain, that says, oh, I'm gonna go to 1, check with this, if it's greater, I'm gonna make my position here. But I still have to check everything, because with 2 I can go to index 1 and 2. So you say, then I'm gonna come to 2, then see whatever is the bigger value, I'm gonna jump in there. That's exactly what I will do right now. I say for I in range of what? In range of position plus 1, because always we are starting from the next one. Position is here, we are starting from position plus 1. This is a pattern that you have to catch. Till where we need to go? Till the power plus position, power plus position plus 1, right? Now the plus 1 is to end the loop, okay? If I don't do that, it's just gonna do, because we are starting from position plus 1, so it's starting from 1, so if I terminate it, I have to increase one value, okay? Now see, what are you gonna do? Just as what you were thinking, that's what, see, right now I'm thinking and I'm transforming that into the screen, and I say if array of I is greater than array of what? Array of position. Are you sure we have to say array of position? I'm saying if array of I is greater than the power. We can write here power. If array of I is greater than the power, what we gotta do is, if that is the case, I want you to change the position. So position is equal to I, which is 0 and 1, right? The value will start at 1. This will be 1, then it will be 2. Once it goes to 3, it will break, right? Now this is done for just these two iterations, right? Now if we want to make it dynamic, what we're gonna do, we have to put this in a while loop. I'm gonna say while position is less than the length of array minus 1. I want you to do this thing times and again. And once this is done for this, and we iterated the list, the pseudo list, this 1 and 3 for this value, what we gotta do is we gotta make sure that we jump now. Here, now I know. Now I know here. I know that, oh, okay, now 3 is the bigger value, right? Or whatever this position is the last position, whatever it is, it will, when this for loop is done, the position, the value is the last value which this condition is met, right? So I'm going to say now I want you to jump, make jump equal, increase the jump, and make my power equals to whatever position it is, right? So I'm going to say array of position, right? Now if I say print jump, you see what's going to happen. We will get 3 jumps. You see, from 2 index 0, I'm going to come 1 jump to here. From 3, I'm going to take 1 jump here, and this is 2 jumps. From directly I'm going to go to the last one. This is 3 jumps. So in 3 jumps we can cross this if we start from here, right? Now of course this is not a very optimal algorithm. There are many cases which are left. That's why they ask you in interviews like, hey, can you optimize this? Can you do something? Yes, I can do that right now, but I prefer not to. Now what you do, you can take this code and add cases. What if you have values as 2 and 2? Then what's going to happen? Because this condition is not going to fulfill that. If array of I is greater than the power, what if array of I is not equal to the power? You have to check for that condition also. If it's equal to the power, then you always want to jump to the last index, right? To the last value of I. Always you want to jump. This is one case. Another case is you can say, for example, it's 6 and we have 1, 2 in here, right? I'm going to tell you, you're going to code that, okay? So we are at my position is this, my power is 6 plus this, which is 0, 1, 2, 3, 4, 5, 6, 7. 6 plus 7 is how much? 6 plus 7, 13. Now see what happens is, now I don't even have to iterate this. Why should I iterate this? Because I already know. That's what you are transforming my own neural network in this. Right now, this what you see is how I thought in a very primitive way about how to go through this algorithm, right? Now, I might put a condition in here and say if, let's suppose I might put a condition in here. I'm just going to write a pseudocode. I'm going to say if, check something. If my position, I'm going to say if position plus power is greater than the length of array, then I want you to do something. If this is greater than the length of array, I just want you probably, I'm going to say jump plus equal to 1. That's it, return, right? This is one thing. The other thing is, what if you are given in here 10, right? Like 12 greater than the length of array. So you might even have, before even entering in here, you might even have it here. You don't even have to enter. That's how you can increase the speed of the algorithm. Okay, we don't even have to do everything because we know. Think about it. This code is my neural network on the computer screen. So that's in the same way I know that, oh, I have 12, so if this power is greater than the length of array, I don't even have to enter here. So I might just write here, if position plus power, right, is greater than the length of array, what I do, I just say return, well, I just say return jump equals to 1, let's suppose, right? We can fix the format. Or you can just say return 1. You don't even have to say jump equal to 1. Return 1. So, so what I'm gonna say is these are all the edge cases. These are all those cases that, because right now this algorithm is not perfect, and I don't want to make it perfect at this moment, because you gotta take this and you gotta think about it, and you gotta say, okay, how can I optimize this? Which cases I can resolve? What if there is a condition? What if you are given an empty array? Are you gonna still do this? No. If you say, well, you put a condition here, if it's an empty array, boom, do nothing, right? If I'm given just one element, 12, just return jump, because uh, you don't have to do anything, right? Um, so that's it. This is the idea, and in here we know that. Let me do this thing. So yeah, let's just iterate the same array from 0. From 0 I came to this index. Once I came to this index, right, I took one jump. I know this is my thinking, which I'm thinking right now before moving to code. I'm thinking, and then what happened is uh, I give then when I'm here, the next time I want to run this loop for 3, 4, 5, these values, right? So I give it back the while loop. You think about it, that again gives me the new value, because I already looped, position change, power changed, and then my jumps changed, right? And then these two values, I'm gonna give it back to the while loop, and then the while loop is gonna go back and apply that, right? And then I'm gonna start from here and come to here, and then same way here. Now the edge cases, all the edge cases, you have to think about it. What if I'm given one element? What if my first element is greater than the length of array? What if I'm in the last position? I don't even have to go to check a condition, right? What if I'm here? What if I landed in here? I don't have to check a condition, right? So these are the things. Yeah, think about this, give it a thought, and see whether you can give it sense, and maybe you have a better way of explaining this. So guys, that's it. I will see you guys in the next video. Bye bye.